Now we will see some characteristic of governors. So the first characteristic of governor is named as sensitiveness. It is the ratio of the speed range to the mean speed. Minimum, basically the ratio of difference between the maximum and minimum equilibrium speeds to the mean equilibrium speed. And we know that this difference of maximum to minimum equilibrium speeds are called as speed range. So if a governor is too much sensitive, then it will respond very soon for any small amount of change of speed. Remember, there are two terminologies. One is sensitiveness and second is sensitivity. Sensitivity is the reciprocal of sensitiveness. Okay, so in sensitivity, the difference is in denominator, and in numerator we will use as mean speed. Now the second characteristics is stability of the governor. A governor is said to be stable when for every speed within the working range there is a definite configuration, that is, there is only one radius of rotation available for a single speed or single speed equilibrium speed. That means as its equilibrium speed changes, the configuration of governor or the radius of rotation will also changes. A governor is not said to be stable when there is decrease in the radius of rotation with the increase in the speed. The next terminology or characteristic of governor, that is isochronous governor. Isochronous governor, when there is a speed range 0, a governor for which the speed range is 0, that means a governor having a constant radius of rotation for all the speeds. That means if the speed changes from n1 to n2, the radius of rotation does not changes. The isochronous governor, when the equilibrium speed is constant for all the radii of rotations. And for isochronous governor, we can say that if the speed is constant, then the radii of rotations vary, but the speed remains same. A Porter governor is not isochronous because if speeds are same, so the heights are also same. In Hartnell governor, the condition of isochronism is given by this relation. That means a Hartnell governor is isochronous if it satisfies this equation. Now, in case of isochronous governor, the sensitivity of governor which is ratio of mean speed to the speed range. If n1 equals to n2, parameter becomes this. So sensitivity of governor becomes infinite. Okay, this is not the practical case because in practical situations the friction is also there, and the isochronism is only thought for ideal cases. Next definition is hunting. If the governor is too sensitive, then for a small speed variation, there is a variation of sleeve position. So there is a variation of throttling valve situation. So if a governor is too much sensitive, then the fuel supply will fluctuate rapidly, and this condition is called as hunting of governor. Okay, here you can define it in proper manner. that a governor is said to be hunt if the speed of the engine fluctuates continuously above and below the mean speed. This causes too sensitive governor, which changes the fuel supply by a large amount when a small change in the speed of rotation takes place. That means for a small change, we get a large amount of fuel supply, which creates further fluctuations in the speed of the engine. Next is effort and power of a governor. The efforts and power of a governor is the mean force exerted at the sleeve for a given percentage change in the speed or lift of the sleeve. That means for a given lift or change in the speed, the mean force exerted on the sleeve is called as effort of the governor. Okay, when governor is in a steady state, that means working at a constant speed, then the force exerted on the sleeve is 0. Okay, so no force is exerted on the sleeve when there is no variation in the speed. The power of governor, it is defined as the work done at the sleeve for a given percentage change of the speed. The rate of work done is defined as power. So the power is defined as the work done, simply the force exerted on sleeve and into the displacement of the sleeve. The next definition is controlling force. We all know that the controlling force are the force which balances the centrifugal forces. So in the case of governors running at steady speeds, an inward force acting on the rotating ball is called as controlling force. And when the governor is working for a steady state condition, that means static condition, then outward centrifugal force is balanced by equal and opposite inward centrifugal force, centripetal force, that is called your controlling force, which is Fc is equals to m omega square r. The graph between controlling force and the radii of rotation of balls is called as controlling force diagram. And because by using this controlling force diagram, we can say the governor is stable or sensitive or not. Stable, not sensitive. Okay, so it's the analysis of stability of governor and sensitiveness of governor will be done by using controlling force diagrams. So here, basic of governors are completed from the subject point of view of theory of machines. Now, in next class, we will discuss the analysis of flywheels. If you have any doubt or query related to these topics, you can send your doubts or queries on the numbers given below. Thank you.